Hello, everybody. Thank you guys all for sticking around to the very end for the very last session on Friday morning. So thank you guys for showing up. My name is Dave Edwards. I'm a lead data scientist in ACTNext, which is our research and innovation department. This is my colleague, Pravin Chopade. He's a research scientist also in our artificial intelligence and machine learning division. What we're going to share with you today is a project called Crisis in Space. Well, I guess our project is called Collaborative Problem-Solving X, but we're doing some work on a game called Crisis in Space, and we'll give you guys some information about that throughout the presentation. I just want to take a quick mention of our team members. So our director, Saad Khan, who's our director of AI. We also have Alejandro, who's a research scientist as well, mostly in learning sciences, and then Scott Poo, who's also a data engineer. So he's been doing a lot of great work for us. So, do you want to start here, or?
Yeah, so good morning, all of you. As Dave mentioned, this is the work we are doing on the collaborative problem solving. This is the very interesting work. We are working since last 2 years at ACTNext. So, I want to give the motivation in terms of what is the importance of this work and how we are trying to approach to this work, considering the development of this AI machine learning as well as the computational psychrometrics, the framework which is developed at ACTNext, which is introduced by our Senior Vice President, Dr. Alina Vandavier. So, objective of this game is to measure the collaborative problem solving skill, and in this specific game, we are trying to measure 21st century skills. So 21st century skills, CPS, is also recognized by PISA. They published a report in 2015. And at ACT, we also consider this as the cross-cutting capabilities. So underneath, there are the two important components we identified: cognitive and social emotional learning skill. So these are the components are important when if it is the measurement of from the students measurement of this skill, as well as these are the skills also useful in the workplace. So we designed this game along with my colleagues David Edward. We came with this idea. Initially we worked with a human agent, and then we started for human-human interaction. So this is Crisis in a Space 2-player game. In this game, we have different setup that I will bring in this presentation. But before going to that, there is a artificial intelligence machine learning. It is playing important role in the different fields. So how we can use of this AI machine learning if we have to capture different components. This game we capture audio, video, eye tracking, game logs data, and when we have this data, we have to get meaning of this data. So getting just the data is not important, but we have to get this data and at the same time see that how it is representing some of the skill information. So with the use of this computational psychrometrics, what we are doing, I just want to give you the brief overview of this framework. So this computational psychrometrics framework has a component starting with the telemetry, feature extraction, then the higher level construct, psychrometrics and cognitive and learning models. So basically, when we extract the data, that is called as the telemetry data. Then once we have this data, which is coming from different multimodal fields, audio, video, eye tracking, we have to extract some of the component, which we just consider the example from the audio. When we extract the pitch, rhythm, that we call as the low level features. And then we have to we go for the more higher level construct in terms of the utterance or correct words spoken in specific communication. If there are the video files when the players are interacting, what is their facial reactions, then other different data. So all this data is considered as the higher level constructs. So even when we have this data, still they are not meaningful, because when we have to give someone the measurement of his skill. If someone want to rely on our measurement or assessment and it need to be validated, so we need to bring the psychrometrics and cognitive learning model. So these are again laid out based on once we have this data, then we measure these specific skills using this cognitive learning model. So specifically Bayesian knowledge tracing or based on the Bayesian evidence, hidden macro model. So these are the higher level theories we use in this computational psychrometrics. So we have this game, we are using AI machine learning, but merit of this work relies, which is based on this computational psychrometrics framework, because once we have this data and we have this information about the participants game interaction, when we are giving about their skill, we are making use of the computational psychrometric model. So to give you some information or the background of this game, this CPS game at ACTNext, we started with the human agent, that is we call as the circuit runner. So in this game there was a human and agent interacting, and agent was designed by us. So task was to find a broken capacitor. So when human was interacting with the agent, there were only few responses. So agent was just responding based on the design 10, if there are 10 options. So agent was not able to provide any additional option if there is a new situation. So we learned from that human agent has some limitations. So that motivation we use to design this human-human interaction. So at the same time, we are not only the ACTNext is not only the player for this design of CPS, but at international level, ACT 21st CPS assessment, this is in the Australia, they develop. In ETS there is a tetralog, that is another human interaction game. But what we observe when we want to measure this specific interaction or collaborative problem solving skill, if we have the real human, and if this real human perform this task, they are giving the free form of responses. And at the same time, another important thing is, now if we have the participant from say one specific region, say North American region, if it is from Asian region, or from the different geographic regions of the world. So this makes more sense, because if we have to make this game to measure as a formative measurement as a tool, so this will be very useful at the international level. So this is one of the other motivations, like having the human play the game and provide us a data. So to give the background in terms of the theoretical constructs, as we have to measure this CPS, cognitive and ACS skill. So we use the approach from the holistic framework. At ACT, we have this broad framework developed to measure the skills which are important, required for the students in the educational as well as to be successful in the workplace. So starting with the academics, we have the component core academics with the math, science, English literature. Then this is the important component which we consider as the cross-cutting capabilities. And under cross-cutting capabilities, we define the collaborative problem solving skill. And there are, again in this CPS, there are two major components are defined to measure the team effectiveness and task effectiveness. So initially we started with this study based on this theoretical framework, and we also tried to see how these specific sub-skills which are under team effectiveness and task effectiveness, like clarity, communication, then strategy when someone need to decide find some task, how effectively they are doing. So initially we spent time to study this specific framework, and based on this specific component, then we made our more research, try to see if we have to go for more cognitive and ACL level, then we brought our framework. So this is again based on our previous research, which is we use from the holistic framework. So this is our main framework. So Dave will give more information about how this crisis in a space game is designed. This is a component. But apart from the CPS, when we have to measure this cognitive and ACL skill, we also have the component ACT Tessera. I think some of you have seen in another presentation. This is the very important framework at ACT developed to measure social emotional learning skill. So when we did the pilot, so we also use crisis in a space game. Through this game, we collect these different interactions through audio, video, eye tracking, and we also ask participants to provide information about their gameplay experience. We want to know if somebody is good in, if they have the background about the playing with some computer game, or if somebody don't have the background with the computer game, whether it plays any role. So we want to know literacy, awareness about some of these computer game has any relation to the success or failure of specific game outcome. So we ask this CPS questionnaire, then ACT Tessera. So in ACT Tessera, this is a separate component, but when we measure these skills which come from the game, afterwards we want to do the correlation analysis. Like if we are getting the information about social emotional learning component from the ACL, and if we are getting the information about the same participant from Tessera, is there any correlation? So this is another objective, and we also ask participant once they play game in two settings. First they come in first week and again they come in second week. How is their experience after the game? How they learn? Why we are asking them to come two times? First, when they come, they perform, but when they come second time, we want to know whether learning is playing any role. So we have the performance outcome for the first play, then for the second play. But we observe that yes, learning plays an important role. In this game, there are 5 missions and 16 sub-tasks. When they come first time, they may be able to complete say 3 missions and few tasks. What we observe, when they come second time, they were able to complete more missions, so they were confident. So that was one of the component. So underneath this framework, so these are the 2 major components. So under cognitive, we have this individual knowledge building, team knowledge building, decision making and monitoring, and in the ACL skill we have leadership, cooperation, relationship. So when someone is playing this specific game, he need to apply his own individual knowledge to perform some tasks, as well as he need to have good team cooperation or teamwork to complete this task successfully. At the same time, they need to also play the role of leadership, because this game is time bound. Some missions are 5 minutes, some are 6 minutes. So they need to coordinate in such a way that the team need to execute the task in a way the information is shared properly, and they need to find specific solution in a given time. So someone need to sometimes play the leadership role. There are some tasks in this game, they are complex. So we also try to see if someone is performing in initial task, if there is a more critical mission, how they are performing in this complex situation. Like if we want to measure how is the person's performance if he works under pressure, if there are say sometimes timeline in a work, how you try to cope up. So our game is designed also to measure how he is performing well even in the complex situation. So at ACTNext, what we this is our again core work. We design our core this framework setup to measure these specific skills and to collect the data. So what you see here, there is a webcam which is used for the Skype. There is audio. Two participants, they sit in a two different room. This game was also available on the web platform. Initially we did the pilot with the web, and then we also used standalone machines to play the game. And this is eye tracking bar, so this measures this is mounted on the machines, or we can also mount this on the laptops. So this is a very natural setting. Participant just come and sit, and they just need to use the headphones for the audio conversation, and whenever they interact, we also capture the screen through the video. So we have also the data come from the mouse click. So we have the game log, we have the audio data, we have the video screen, we have the eye tracking data, and through this we are getting the 4 modalities, and then later we work on this modality to extract, to apply machine learning component. So before going into more detail about this AI machine learning, they will give you more details about what this game, astronaut and engineer mission to Mars, and how then we are approaching for some of the pilot studies.
Thanks, Pravin. Sure. So basically what we're trying to do here is we're trying to get students to collaborate with each other, and so we can watch them, so we can actually evaluate their collaboration while they're doing it. And we want the AI to be able to watch them do that and score them and evaluate their behaviors as if a teacher might do while they're watching the players play. So that's really the core point of our research, is to try to figure out a way of watching people collaborate and see if we can score that in near real time. So as Pravin was mentioning many times, we have this 2-player collaborative game that we have players play, and this is the environment that we put them in order to elicit these collaboration skills. So the way that this game is designed, it forces players to collaborate because there's no possible way of succeeding on your own. The information that is required in order to succeed is fundamentally divided between the 2 players, and there's no possible way for one person to have it all, unless, now strictly speaking, you could, if you had a really good memory, you could remember all the rules, but the rules are designed to be a little bit unclear. Well, not unclear, but complex, so they're very hard to remember. And so you have to refer to them constantly in the booklet. And by referring to those rules, basically we get to collect information about where their eye tracking is going, how their reading skills are doing, and different kinds of things like that that we can use in order to figure out how they're behaving. So I'm going to take a little bit of time to explain to you guys what the game is, how the game works, and then hopefully through that explanation you guys will understand that this game definitely does require collaboration, and it elicits collaborative behaviors. And then really the only question that we have left is, can we collect this information, and can we develop artificial intelligence and machine learning techniques in order to be able to recognize reliably these information, and then can we collect this data on a large enough sample that we can sort of figure out how to aggregate it together into some sort of high or low scale. So the game itself is played in a browser, and so this makes it platform independent, which is really important. A lot of schools have like one-to-one with Chromebooks or something of that nature, and so definitely it's platform independent, so that's a key feature. Now for some of our research, obviously, we're doing a lot of collection of data with eye tracking, screen recording, and Skype phone calls. So not all of this data stream is going to necessarily be available in the deployment of this tool in the wild. And so what we're trying to do as well is we're trying to build sort of a layered approach so that the information that we have we can use in the estimation of the collaboration skills, but that the information that we don't have, while it would improve our estimates, it's still something that can be done without it. So in particular, the main thing that we're really looking for is their conversation, although the rest of the information is very important. So this is a really busy slide, but that's just because there's a lot of information about the game, and so it's all fits kind of together into this one slide. So the basic idea is that the two players are on their way to Mars. One of them is an astronaut on the space station. And we'll just suspend our disbelief about a space station traveling to Mars at this moment. You definitely would want a rocket for that. But the idea is that there's something going wrong on the spaceship, and they need some help from their ground control in order to be able to solve the problems. Now, you also have to suspend your disbelief a little bit more that the astronaut hasn't had all the training they need to operate the machine on their own. But as we've seen in Apollo 13 and other situations, sometimes things unexpected happen, and you need some help in real time. And that's essentially the premise of the game. So the astronaut, so I'll just kind of point over here on this right side over here. So this is a look at what the game looks like for the two players. What happens is the astronaut, and there'll be some more information about this on the slides moving forward, but they have a few hot spots on their space station which have some issues going on. They pop those open, and inside of those hot spots are little puzzles. These are kind of like test items, you could think of them as, but they're a little bit more complex than just, say, a multiple choice item. And the idea here is that there's some puzzle that has to be solved, and that through the solution and deriving the solution to that puzzle that we can exhibit some of these collaboration behaviors. In this particular case, what's showing, and there will be another slide later with a little bit more information, there's some wires on the circuit panel which is miswired, and so they have to do a little bit of repair to those wires. And then the engineer has a collection of information that lets them know under what circumstances which wires should move where and things of that nature. So they have to share the information back and forth about what their circuit board looks like, what color their wires are, how fast their ship is going, some other information like that. And the engineer can navigate through all of these different conditions in their manual. Pravin mentioned this briefly, but here's a little diagram of it. So when two players play the game, at least the way it's set up now, you play through the game for 5 missions. One mission is kind of a time-boxed experience. So one mission will have it'll have a timer, and then it will have some specific number of puzzles or tasks that need to be solved during that period of time. And then after that time is elapsed, or whether you have succeeded or failed at the puzzles, then there will be an intermission period, which kind of looks like this screen, where the players have a chance to stop, reflect, talk about what they learned, talk about what they did, what went well, what didn't go so well. And we use this time in our data collection actually in order to look at a lot of information about checking in with their partner, developing shared understandings about what kinds of mistakes went wrong in the previous session, or what kinds of things went well. And so by dividing the data collection up into time-boxed and non-time-boxed segments, we're able to watch the players execute on strategies during timed segments, and then reflect on strategies and develop their relationships during the non-time segments. And so this design allows us to elicit both collaborative behaviors while you're on task and collaborative behaviors while you're off task, and you're just kind of trying to develop your team and develop your strategy. These are both different components of the collaboration construct, which Pravin referred to previously. I think that's enough on this slide. So here's a little drill in here. So what you see in each of these things is a mention of, say, wires or keypad or asteroid. So these are our 6 item types that have been developed. And each item type has its own particular manner in which it appears, its manner in which it is solved, the key information which is required in order to solve that one. And what we look at is we watch as players slowly learn to understand what is the key information that's necessary, what is the order in which they should share that information, so the engineer can navigate through the instructions as efficiently as possible, which actually turns out to be an important thing given the very short period of time that players have in order to complete the missions. And so what we're watching for is we're watching for them to develop these strategies, pick up on these key information, and then check in with each other about which information and what order they should be sharing it in, because the engineer has to navigate through the instructions, and they know which information might be most useful to them at some moment in time, whereas the operator is the only person, the astronaut is the only person who has the information that they have access to. Here's a slightly more blown up version of those screenshots that you saw on the previous slide. In this particular deployment, there was a chat window that they could talk to one another in. So we found that the chat was pretty useful, but we got a lot more robust communication and varying behaviors when we actually put the two on the radio with each other. Well, I suppose they would use the radio in space, but we just use Skype. But the idea basically is that when you're typing, you take a lot of time to come up with your thought, enter the information into the keys. There's a lot of keyboarding skills involved there. Whereas when you're just talking to your partner, there's a lot more train of thought that's going on. It's a lot wider of information that is being shared. The astronauts over here, they've got a couple puzzles which actually, I don't even see them labeled there. But then over here, the engineer has a handful of rules. None of the rules are on that particular screenshot, but there may be some here.
Chat as part of data as well?
Yeah, definitely. So what we did with in the experimental case where we had the chat, we interleaved the chat with the transcript that was automatically transcribed from the audio file. And so basically we, in the telemetry file, we know at what point these chat statements were logged. And so then we're just interleaving those with the actual speech. And it was actually kind of interesting. I don't know if you guys, I'm sure all of you spend some time on video conference calls, but the moment that the chat is made in chat is not necessarily the exact same time that somebody notices that it's there and reads it. And so in that context, actually interleaving the chat at that moment compared to another moment is not necessarily the best case, but we're working on some ways of trying to figure out at what point they recognize and mention that the statement is in there. But this is actually, the chat is only in a small portion of our data set. We decided that to kind of take the chat out and mostly focus only on the spoken conversation. But that is what we do. Thank you for that question. Are there any other questions about this or anything up till now? Please feel free to interrupt and ask questions. This is a very, yeah.
So the target group, the age group is?
Yeah, so our target group right now is between 12 and 18. In our pilot data study, we also included a number of interns who were working here at ACT, so we do have some data up to the postgraduate level for some PhD candidates. And what's actually very interesting to us about some of the insights that we've learned from this, because this is a gaming situation, which is kind of disjoint from any prior experience that you might have, actually experience playing games is kind of the more predictor of doing well as opposed to education level. And so we actually find that the difficulty level is appropriate for people all the way from age 12 up to about 28 or so, simply because you don't know what the rules are. You don't know how to play this game yet. But as you play, you start to learn more. So the middle school students actually surprisingly did learn similarly quickly to the college students. So, but we are looking for more data in the future to look at how the age will affect the behavior and performance. Thank you for that question. Here I'll just give you a quick walkthrough of one particular task just so you can kind of get a sense of how the information is collected and shared across the line. So in this particular case, this is the wire cut task or the circuit board task. So what's important about this one, what's really important about all of them really is that the operator, the astronaut, when they're presented with this task, there are no instructions. They don't exactly know what it is that they need to do. And so the key thing that they have to do first is explain to their partner what is the situation, what it is that they see, what's going on. And so what we notice is we notice people will describe this circuit board. They'll say, oh, I have a circuit board, I have a microchip, there's some wires, and they'll start describing different elements of them. Sometimes they won't actually start focusing on the task right away. They'll start describing a lot of other things about their environment, like that they have a clock and some other information. And so we look at this as how quickly they're able to focus on the task versus being distracted by other information. Once they've identified or described this task, their partner has to figure out which of the pages of the booklet are relevant to the thing that they're doing. And what we notice is that early on that they start out describing the task very much visually in terms of what it is that they see. And as they've played a number of times, they start to develop a shared understanding, and they can very, very quickly just name the task, and then they can very quickly become on task. So people will call this one wires or circuit board, and then the engineer can click on the circuit board page, which is here, and get those set of rules. So we look at the difference between people who are describing the task, and once they've developed a shared understanding, they can just simply name the task, and that the partner knows what they're talking about. So this is an important part of collaboration, which is developing a shared understanding of the situation at hand. So if you read through this engineer booklet, the first statement up here is the instructions, which gives you the actual objective of the task. It says that the circuit board is going to spawn with between 3 and 6 wires, and that the objective is to cut 1 wire based on this collection of rules. So once the engineer has read this, sometimes they'll read this out loud, and so we notice that some people, they'll read it out loud, and some people will read it and paraphrase it to their partner. We think that some of the things like reading it out loud is a behavior where I want to give all the information that I have to you, which is sometimes efficient, and sometimes it's more that they look at it and they distill it and they say, oh, how many wires do you have? And so they just jump right to the question, which is the first piece of information they need, which is to figure out which of these paragraphs they need to be in, which is how many wires there are. So we can detect the difference between when people are just reading out loud from the text versus when they're reading and paraphrasing the information. And so we have yet to exactly know precisely which direction is like better or say worse, but I don't necessarily think that there's an objective question to that. I think it's about how effectively the team works together. So the first piece of information this person is going to need is to know how many wires there are. If you already know that, then you can just look here and say, I have 4 wires. And then the engineer is going to go ahead and focus in on this paragraph. So our eye tracking allows us to figure out that they're focusing on this paragraph and they're reading it here as opposed to scanning up and down here. Sometimes different kinds of failures that people will do is they'll jump between paragraphs. So they'll read rule A in one paragraph, then read rule A in the next paragraph, and then rule A in another paragraph after that. And so these are cases where the person is not necessarily executing well on strategy, and that will ding them on the cognitive scale. The first rule here for 4 wires is it says if there are 2 or more blue wires. Well, looking over here, there in fact are 2 purple wires, not 2 blue wires. It's a little bit hard to see in this slide because of the projector, but on the actual computer screen, the difference between purple and blue is quite clear. So there are not 2 or more blue wires. But this is an and statement, so there's two predicates in this if, so there have to be 2 or more blue wires and the orbit type has to be elliptical. So since there are not 2 or more blue wires, we want to reject rule A and move on to rule B, which says otherwise if the wire furthest to the left is purple, which it is, and there are no blue wires, which there aren't, then collect the second wire from the left. And so what we're hoping is that we see them ask these 2 questions. Now these 2 questions can be asked in a lot of different ways. They can say, is the furthest wire to the left purple? They might say, are there any purple wires? They might remember because this person started out by saying purple, yellow, white, purple. And so they might remember that the first wire is purple. And so that's one of the things that we're doing with our machine learning model is we're trying to estimate whether or not the person is aware of the information and then whether or not they act on that information sort of independently of one another. Or whether or not they don't remember the information if they ask their partner for that information again. And you can imagine that there are a number of different ways of asking a question which will get at the answers to these 2 questions, whether or not the leftmost wire is purple and whether or not any blue wires are there. So one of the things that we're doing here is that we're looking at compensatory behaviors. So for example, if you told me there was purple, yellow, white, purple, I don't need to ask you what the furthest wire to the left is because you did tell me, and I don't need to ask you if there are any blue wires because you did tell me. And so I can just say cut the wire second from the left. And if a person just says that without asking any of these questions, then we sort of can think of that person as having a good working memory and that they're going to be sort of more efficient at providing the information to their partner. So that's just like the wire task. There's 5 more tasks that are very different from one another.
This is the collaborative.
So that's kind of a little bit about the task at hand. And so I hope that through just a quick brief walkthrough of how one team might solve that task and a number of different ways that they could succeed or fail or be more efficient or less efficient, you kind of get a sense of the types of behaviors that we're watching for as people are playing this game. Now, our colleague Adam made a quick video of this game so that you guys can kind of see it in action, and he kind of talks through it.
This is the collaborative problem-solving game, Crisis in Space. In this game, an astronaut and an engineer are working together to repair the International Space Station. This game consists of 5 missions and 16 subtasks. In this video, players are working on Mission 1, Wires and Keypad or Symbols.
So these red spots are the eye tracking data that's overlaid so that you can kind of see what it's looking at. It's a little jittery just because of the particular rendering algorithm we used here.
Alright. Good. What's your first thing?
A circuit panel.
Panel. Okay. What are the wires? How many are there?
There's 3, and there's yellow, red, and purple.
So you notice he mentioned the number first.
Cut the, so there's no blue wires, so cut the wire furthest to the red.
So in that case, he said there's no blue wire, so he just said it out loud, asking for his partner, essentially implying for his partner to disagree with him if he was wrong. So these are like checking in behaviors, these kinds of things.
A raindrop thing with a line underneath it.
Okay.
A square that has 2 triangles in it. A circle with 2 lines through it, and then coming out the left side, and then there's the circle with the X that has the arrows pointing outward.
Okay.
So in this case, he has to describe these symbols and get his partner to locate them, which you can see he's locating them vertically in this column. And then he'll give him the instructions as to which order to press the buttons in. What's really interesting here is the description of the symbols. They start out a little bit weird, and as they get going and they get a little bit more familiarity with the different symbols, what they do is they start to name them, and they stop describing them, and they just start referring to them by name. So in the particular case, well, I guess I can't pull it up now, but he did say there's a teardrop with a line underneath it. Eventually, they just come to call that the teardrop, and they stop describing the line. And so one of the things there is what we're looking for is at what point in time do they converge on a shared understanding of something that they can just name and refer to. So we do this in business all of the time. We come up with complex ideas and we just give them names and so that we can refer to them in order to more efficiently communicate with one another. So those are some of the different kinds of things that we're looking for in these couple different tasks. The next few slides I think are just going to talk a little bit about the data that we're collecting, and I think we have a little bit of time, so also if you guys have any questions, please feel free to stop me. So Pravin mentioned a little bit of this before, but we have done a few pilots where we've done some data collection, and this slide kind of walks you through a little bit of the data that we've collected. So we did 3 rounds. We've called them pilots 1, 2, and 3. So in the first and third pilot, we collected data from interns, and in the second pilot, we collected data from middle school students. The data set is about 50-50 between the interns and the middle school students. For each participant, we had them fill out a demographic survey so we could learn things about their gender, their age, some of their educational background, and information about whether or not they play a lot of games. So we found that whether or not people play a lot of games is very predictive of their performance and also their ability to help their partner figure out what it is that's going on. So we're looking at trying to control for that variable in the future by asking people in advance whether or not they have a lot of gaming experience, and pair experienced gamers up with each other and pair inexperienced gamers up with each other so that that variable isn't really confounding things as much. And there's also a few things around gender which are interesting. There's a lot of gender human-computer interaction differences between boys and girls, how they interact with computers. In particular, just to give some very high-level information if folks aren't aware of this, boys tend to be a lot more willing to take risks and just click on things and find out what happens. Girls tend to be a little bit more reserved and really want to know what's going to happen before they click on something. And that's just one small example of the differences. And so we are really interested in different gender variables as it comes to this, and also, as I'm sure you can imagine, working with a partner who is either the same or opposite gender as you can potentially change certain behaviors that you'll have. And there's a lot of sort of leadership and following that happens in this game a lot, and we're very interested in seeing whether or not people are willing to both take on the leadership role and also take on the follower role, because by design the game actually forces one person to be the leader at varying points in time, and we're watching for whether or not people are doing that. We also have some independent collaborative problem solving results. So as Pravin mentioned previously, current state-of-the-art measurement of collaborative problem solving is primarily survey-based or situational judgment-based. And so we have them take some known collaborative problem solving metrics so that we can correlate to those. We had them take a post-game survey. This is like, was it fun? Was it stressful? Did you find it very hard? Did you find that your partner worked well with you? Did you think that your partner did a good job? Do you think that you did a good job? Different kinds of things like that, because we are also interested in self-assessments of collaboration. Since mostly collaboration is measured through self-assessment, we want to know what they thought of what they did compared to how our measurements work out. And then obviously we also have them take the ACT Tessera battery, because this is a very much state-of-the-art social emotional battery. It does a lot of great things. We also collected all this data inside the game. So Pravin mentioned we have audio, video, eye tracking data. So we're recording their facial expressions through this Skype. We're recording their screen, what they are looking at, what they're seeing at any given point in time, so we can overlay the gaze data with that. We're recording their conversation, which then we're automatically transcribing, then doing a lot of natural language processing on. And then, of course, we have game logs, so we know what they clicked on, when they clicked on it, whether they were successful, whether they're unsuccessful. A big thing with that is that sometimes there's not the exact same thing between I gave you an instruction, you agreed to do that act, and then the thing that you did may or may not be the same. And so that's where the telemetry can come in really very helpful. And then the eye tracking data also lets us know where they're looking at what points in time. So we can see different sorts of strategies to how they're searching for information, or whether or not they had access to the information that they're supposed to have had. And whether or not they're looking at their partner, because the Skype video is actually on the screen as well. And so we can see when players are looking at their partner, which especially happens when they're asking or waiting for information. The rest is just some very high-level information about some of our initial results. So
Before, we go to the details. Any questions on the
so
game
we'll
part?
stop before we go.
Yeah, because
into
now we will be
detail.
having some analysis, and then I'll again bring machine learning part. But
Yeah.
if we have any questions on the design parts.
We'll talk about the data collection and how to transform all the speech and talking and collaboration into data.
Yeah, that
Yeah.
will be is
Okay.
coming.
Yeah, we'll talk about that a little bit in the future, but our raw data set is video recordings largely. So we put a lot of those through some out of the box algorithms. So we use Amazon transcription service to transcribe our MP3 files into text. And then we can, once we have text, we can use all manner of different NLP technologies on that. We take some of the facial data and we feed that through sort of a known facial recognition software that estimates facial expressions and affective states like frustration, happiness, anger, these kinds of things. And then we do some machine vision on the screen in order to locate where on the screen certain things are, because some things can be dragged around, and so they're not always in fixed locations. And so, or as you can see, there's some scrolling also that happens. So we use some machine vision to make sure that we know where on the screen different items are. And so a lot of it is like there's a lot of data integration step. But after all of that comes online, there are different kinds of features of what we're looking for that we'll talk about in the machine learning segment, where we're trying to extract things out of the conversation, like, is this a question? Is this an answer to a question? Does this answer contain the key information that they're looking for, like how many wires there are, different kinds of things like that. And then what we're doing is then we're aggregating those into sort of higher level behavioral indicators, which will, I think there's a slide that mentions what some of those are, and how those ladder up into the actual measurements of the construct. That's a great question, thank you. Any other questions? Okay, please, again, feel free to stop me at any point. So this is just really high level information of our very first pilot. This is our first intern study. So you'll notice here in particular that 10 of our 27 gameplays, they did not succeed in a single mission. So in order to succeed in a mission, you have to solve all of the relevant tasks within the time frame without making at least 3 mistakes. So if you cut the wrong wire, that's a mistake. If you push the symbol in the wrong order, that's a mistake. So it's not be like it's important not to focus too much on the fact that people are not necessarily succeeding at the mission level. There are subtasks, so like you might succeed at 1 out of the 2 tasks on the mission, and but you still fail a mission. And so there's sort of a partial credit model that we've been looking into too for this. But the performance actually on the game, one thing I find very interesting about this is sort of negatively correlated to happiness in our data set. So people seem to be having more fun when they lose, which is kind of funny because at least part of the way in which you lose is a little bit comical, because a lot of times when you lose, it's because like you didn't know what to do, or you were kind of rushing to make a decision because your time is running out. And then because it's a game, it doesn't really matter that you lost. And so then when it pops up, it says mission failure, and you're not really sure why you failed or what you did to fail. Then they just kind of laugh and giggle, and they try to speculate about what it was that went wrong. And what's really interesting about that is that really encourages them to try again because they really want to get it. And so that's one of the big things we think is very valuable about this project, is that even when people don't succeed like visually in the experience, they're actually succeeding at like developing rapport with one another and becoming better friends.
Do you also track their improvement over the course of the missions, not necessarily just accomplishing each mission?
Yeah, we don't have any specific data on that, but yeah, definitely between gameplay 1 and gameplay 2, people did do much better. So let me just really quick talk about that for a second. Pravin mentioned it very briefly, but what we did is we had all of the participants come in and they played the game once, and then 1 to 2 weeks later they played the game again. And what they the different partners actually in each case. So we had them all have different partners. There were a few pairs that had the same partner, but mostly that was based on like scheduling, really. And so a lot of the random pairing was actually not deliberate. It wasn't based on specific experimental conditions. It was more based on scheduling at this point, but we definitely have, as I mentioned previously in some of those confounding variables, we definitely have some specific ideas of what we want to do with doing deliberate pairing as we go forward. But the one thing that we did control for was whether or not the players had played the game previously. So the first time you play the game, you play with a partner who has not played, and the second time you play the game, you play with a partner who has played. We think that this is the most important feature there because there's a lot of information that you pick up the very first time through, like what are the 6 tasks? What do I have to do when the wires pop up? What do I have to do when the symbols pop up? And so those are the kinds of things. And so definitely people did much better the second time because they were spending less time trying to figure out what to do and more time doing it. And that was actually on purpose because part of collaboration is also learning what it is you're supposed to do. And so we see the first 5 missions as sort of going in one direction as far as the construct goes, and the second 5 missions going a little bit more in another direction. So the first one is really about relationship building through trials and having failures, and also then learning and developing strategies. And then the second time through is more about maintaining that relationship with your partner and then executing on those strategies in order to succeed. And so we actually see the 2 sessions as being fundamentally different. But yeah, they do perform better on missions 6 through 10 than 1 through 5. This is some high-level information about our middle school students. So what we did a pretty good job, I think, of getting a 50-50 split between boys and girls. So we have 25 and 24 here in our middle school data set. And through this we had about 50 students play. In this particular case with the middle schools, most of them are 13 to 14, so this is 7th and 8th grade in the States. So this is a really interesting social time for them. These are some high-level demographics. So most of them, English is their first language, but for some of them it isn't. This became pretty apparent in some of the transcripts, but we're very much interested in looking at English not as your first language and also other languages, although right now we're focusing on English because we live here in Iowa. This is one of the really interesting ones we thought. So we asked them how well they knew their partner, because since it's a collaboration game, we were really interested in are people who are already friends going to do better or worse? But what we were really excited to find is that before they played the game, there was kind of a little bit of a mishmash of different people who knew different people. Again, this was based on scheduling, and we did this during the school day, and so the participants who were playing were pulled out of class. So there's also a small selection bias on GPA there because students were not permitted to miss class and participate unless they had like at least all B's or something like that. So there's a little bit of bias towards the top end of the GPA spectrum, but yeah, we're gonna do some more stuff probably next summer that will kind of correct for that. But here, this is the real interesting thing. So after they played the game, everybody felt pretty much like they knew their partner much, much better than they did before. So this is something that we were really excited to see because basically the whole point of working with another person is getting to know them better, figuring out how to work better with them and things like that. And so we actually have some very initial findings that this is working very well. So that's kind of a lot about the game itself, some of our initial pilot studies and those kinds of things. And Pravin is now going to dive into some really interesting details about how we're using the machine learning techniques in order to do the actual measuring.
Thank you, Dave. So we have so far information about what is our objective in terms of designing this game to measure the collaborative problem solving skill, then what is the specific data collection setup, and how we did this different pilot. As Dave mentioned, we did this pilot both for the middle school student with the age group from 13 to 17, as well as the graduate students for our summer interns 2 times. So we are getting this information from the different age group, and they already mentioned that some these middle school students also performing at some quite good. So now we want to use this data to see how we can implement. Initially I mentioned that our objective is to use this AI machine learning as well as computational psychometrics model to get the meaningful information. Now if we are to develop some scoring framework, like once they play the game, the total time frame for the game is 25 to 30 minutes, and if we are to, after they perform the game, we want to give them information about some of the skill. So this is our approach now to use some of these machine learning techniques. So at present we have this data which is coming from the game. We have this audio video eye tracking, and finally we want to get to know about their cognitive and ACL skill. So there is specific audio data which at present we are successfully work. We are also looking into the video analysis and eye tracking. But when we are getting the information from this audio data, mostly as we have this data available in audio format, then we convert using Amazon Transcribe these audio files to the JSON file, as what we call as from JSON to the text file. So we convert all this participant data from audio to text, and on this text then we implement this natural language processing and most advanced techniques which are available, and at the same time we are also doing our own programming to implement further some of the skill evidence. So some of these methods which are listed here. So we are using NLP for the feature for the turn taking analysis. So we have the transcript for the astronaut engineer, and when they speak there is a specific turns like a specific question and how there is a response. So for that, and we also use recently in 2018 Google developed universal sentence encoder. So this is we use for the turn embedding. So this is specifically used, like we have this transcript. Sometimes these transcripts, when we convert from audio to the text, it misinterprets some text. Like if there is a word keypad, so it's not sure that sometimes this word, when it will person is speaking keypad, and when it will be converted into the transcript, it may miss some word. So instead in keypad it may miss K, E, Y. It sometimes may miss say word Y, but without specific word say Y, it is not meaningful the keypad. So when we try to input this vocabulary or turn embedding, so it will try to correct this word. So when we implement this NLP methods embedding, it also helps us to improve this transcript. So if there are some missing word, so it will in a transcript. So embedding helps us to improve this transcript, so that when we try to see how many correct words are spoken in specific interactions, and if we have to see that if these are the correct word about the wire, because we have to get information about the skill, so we need to use some of the improve the vocabulary, and this is to use the turn embedding. So yeah, so this is the one of the specific methods which use for the audio. So we get the audio files, then we perform this low level feature analysis like their rhythm, pitch. At the same time, we use this text in terms of how this number of correct words spoken. Now this is one example in terms of clarifying question, information seeking between them, how they read the booklet, and based on this data, then we also embed some of the number of positive and negative words. So we did this sentence embedding using the SVM algorithm. So this is the method we use for the NLP. Like we extract this stop word, streaming, tokenization. We find the facial tokens, like highly spoken words. If you see in Pacific Mission, they have to read out the symbols. They have to get the wires, provide the specific information related to the specific mission or task. So we extract that highly spoken word from that specific transcript, and then we also perform like a bag of word. These are the common techniques using natural language processing, TF, IDF, word embedding, and early analysis. We use this LDA and LSM method and try to plot this specific sentiment analysis. So what we did, we embed some of the positive word spoken and negative word spoken. So here is the example. We collected, combined this transcript from the summer 2018 pilot, and here you can see it here. So like when they are very positive about the game, interesting, helpful, accomplished. So we can see like how positive they are. So these are the some early sentiment analysis about highly positive word in the all the 23 participants, those who play from the summer pilot. Sometimes when they are failing, they see, okay, this is a very hard, frustrating. So you can see here, it is a very complicated. If they are not performing, they can see their reactions. So this is the way when we use NLP and when we apply on this is specifically the results for the graduate student pilot 1. So we get to know like how sometimes they are positive, how negative their reactions are, and this also get to know about some of when we have to relate these things to the skill mapping. So this is one of the technique. So before I go to the video part, any questions on the audio part? Like this was the very basics. We at present we are using more advanced techniques in terms of turn taking analysis, measuring the cohesion, sentiment, agreement, confusion. These are the another component, but they are not part of this presentation. But there are more advanced techniques we are using for the audio data, because most of the information is coming from the audio conversation. But we also have the video data. So we use the video data, like this is one of the example from the summer pilot 1. Like when they play the game, we see it here. There are the different emotional index, like how happy, how sad, how frustrated they are, how sometimes when they play the game. So based on their facial interactions, we put this video recording screen to the Node.ls, and it generates these specific expressions. So we also use this expression in terms of deciding, like if you when you saw the video, how happy they were when they finished the task. They were really happy. It also is a good gesture in terms of the team. So sometimes when they fail, we really get to see like how is their reaction. But at the same time, we observe like gaming makes gaming makes sometimes as a fun. So they also try to sometimes learn from the game, and when they go for the next mission, they are really work as a team. So these are the some of the components we get to know from this interaction. So this is the view for the engineer. We also try to combine this with the other analysis. So these are the another affective state in terms of their left eye, right eye, how is their mouse movement, mouth positions, or how there is head orientation. Like sometimes sometimes some person, when he answer as a yes, sometimes they utter the word, sometimes they say just by the head. So we get to know, like it's not only the word spoken, sometimes body posture also gives the information, like to answer some of the things. So we get this information from this video feature analysis. So this is again some of the ongoing tasks. Our objective is like develop this kind of framework as a user interface, like when they play the game, and after this there will be inside there will be this machine learning algorithm which will extract the different skill and which will try to see, and they will get this kind of a scores. Like this is just the example, like how good these are the like a teamwork, communication, or strategy or engagement. So like in terms of the star, so we'll be converting all the information coming with the different skill to the different probability values, and we'll then try to put in terms of the different star rating. Like they are 3-star in communication, they are 2-star in the working together. So this way we can, again, this information will help team to improve on some of the skill. But this is the way we are planning. This is just the mock-up of our GUI. And finally, what we learned from this game in terms of this game has following the very robust constructs. As I mentioned, we are using these CPS skill, which are the 21st century skill, and these are the skills required for in education as well as for the workplace to be successful. So this game setup helps us to measure this skill. At the same time, other important thing is, if we ask the student to go on paper and pencil as a go for test, he is always in a pressure. But whereas what we observe, they come and play, they are really very happy. They never feel any pressure. They play the game, they give work on a task, but on the back end we are measuring their skill. So gaming makes this measurement very easy, both from the administrative point of view as well as from the those who are participating. And even they fail, they always want to improve. So see, this is a positive thing. They will, even if they not performing on some task, they always see the response. Okay, we'll play again and we'll improve. So some of the things are making more easier. So this is one of the tasks. And another things what we are trying to do in future, like we are using the subject matter expert to manually code this thing. We are getting the scoring from our machine learning, but we want to first make sure that some of the coding coming from human and machine, they are mapping. So this is the first validity. Once we know there is some good match between the machine score and human, then we can rely on the machine learning. So this is the one important thing we are doing, and we are also working on using some of the more advanced work on audio analysis and using more algorithms, sophisticated methods for this specific framework development. So before we end the presentation, we want to thank Dr. Alina Vandeweer. She is our Senior Vice President. She is really the force behind development of this CPS work at ACTNext, starting from human agent to the human-human interaction, and she is supporting us to take this work forward as a method for the formative measurement of this CPS skill. At the same time, our CPS team member, including Dr. Saad Khan, Director of AI Machine Learning, then Alejandro Scott Pu. We also have our project manager to be Drake, and the consultant Dr. Brian Maddox. He worked he helped us to develop this construct. At the same time, all the organization management of ACTNext and ACT, they are also supporting to develop this game and framework. and we also received support from the LRNG. Previously it was Glass Lab to develop this work. So these are some of the references which are a part of the work. And again, before I end, I want to thank you all for coming here from all the part of the world and patiently listening to our presentation, asking very interesting question. But thanks to organizers of this ACT Learning and Measurement Academy for giving us opportunity to present our work. But we welcome questions and we also, if you have any inputs for improvement, please.